Welcome back to my physics breakdown of Dark Souls 2. Today we'll cover vertical motion. In the last video, we went over some standard units and horizontal motion in Dark Souls 2. Another bit of information we can find easily is the player's vertical acceleration due to gravity. Now that we know the player's height, we can use that to find the height of a few places in the game. The most straightforward, or should I say straight up and down heights to find, are those with ladders. And we have one conveniently placed right next to the same bridge in the Iron Keep from the previous video. Standing beside it, it looks like the player is about 4 ladder rungs tall, and with a closer look it's more like 4 and a 7th rungs. Meanwhile, there are 20 rungs from the ground to the upper platform. This will make the ladder about 8.2 meters tall. Now that we have a known height, we can use this kinematic equation to solve for the gravitational acceleration. H equals v0 times t plus 1/2 at squared. In this case, the initial velocity v0 will be 0 since we start counting the instant the player begins to fall. The height of the fall is h. And a, the acceleration, should wind up being a negative value since gravity pulls downward or in the negative y direction. Note that since we're falling, the change in height will also be negative for the same reason. After rearranging the equation, we get a equals 2h over t squared. I also have a quick side note before we continue. This should go without saying, but do not attempt anything in real life like the falling stunts I show in this video. It's really bad for your joints, and like the entire rest of your body. Anyway, back to the experiments. When testing, the most consistent results came from simply standing at the very top of the platform next to the ladder and falling off. For this ladder by the bridge, falling took about 0.87 seconds, making the acceleration negative 21.9 meters per second squared. Repeating this for several other ladders in Majula and the Iron Keep resulted in acceleration values ranging from about 19 to 22 meters per second squared. These correspond to time measurements within the uncertainty of 2 frames we discussed in the last video. Oh, and how do I find the height of each ladder? By counting the number of rungs myself. All the way down. Anyway, averaging all these together, we find the gravitational acceleration in Dark Souls 2 to be negative 20.6 meters per second squared. That's just over twice the strength of gravity on Earth. This was likely a design choice to make platforming sections pass more quickly, or to make them more challenging. Who's to say? Now that we know the acceleration of gravity, we have another tool to help find the height of any fall in the game. We just need to find how long each fall takes. So, let's go to a very tall building in the game and try it out. I chose the Brume Tower and found a place where we can drop from the same height as the first bonfire almost to the bottom of the tower. How far does the player fall here? The answer becomes a bit more complicated in this case, since the player doesn't keep accelerating as they did before. Looking at the footage, there's a point partway down the fall that the player stops moving farther away from the camera. This implies they've stopped accelerating and reached a constant velocity. In real life, this is called terminal velocity, and it happens when the force of air resistance on a falling object equals the force of gravity pulling on it. At this point, its velocity remains constant as it falls. It would make sense to include a limit like this in the game so the player doesn't accelerate infinitely. Let's investigate how this works. Looking in the background at the Brume Tower's walls, we see these regular columns with distinct sections. By counting the frames it takes for each of the large rings to reach the top of the screen, I can estimate how the player's velocity behaves. Keep in mind that real data is messy though, and rarely matches a simple equation exactly. As shown, the large dots are the actual data points I gathered, and the error bars include the 2 frames of time uncertainty. Some example graphs calculated in Python simulate what we should see if there is air resistance, or if the developers just set a maximum velocity with constant acceleration before that. As we can see here, the graph simulating air resistance most closely aligns with both the position and velocity data, implying air resistance is included in Dark Souls 2's falling mechanics. And yet, the graph with no air resistance and sudden terminal velocity is still pretty close, provided terminal velocity is included after about 3 seconds. Until further research can be done on exactly how air resistance is calculated in the game, I'll approximate it by averaging the other two models which don't include air resistance. This will be especially helpful when calculating much farther falls than this. Using another kinematic equation, v equals v naught plus a times t, we can see the velocity after about 3 seconds will be negative 63.1 meters per second. To get the total distance traveled while falling, we can add together how far the player fell while still accelerating and how far they fell at constant velocity. Then we can average that with how far they would have fallen if accelerating the whole time. For the Brume Tower, this gives us a total fall distance of 266 meters or 872 feet. That's over 8/10 the height of New York's Chrysler Building. We can now apply the same math to find the length of basically any fall in the game, but I picked a few more of the farthest for effect. Keep in mind that we only need to include terminal velocity if the fall takes long enough. First, we have the high tower of Drangleic Castle, and there's even an elevator for us. How convenient! Since the fall is long enough to reach terminal velocity, we apply the same math as before and see it's about 118 meters tall. Next, we have the elevator from Drangleic Castle down to the Shrine of Amana. It's likewise about 127 meters tall, a little taller than the castle tower's elevator. Both of these are a bit shorter than the Kyoto Tower in Japan. And last but not least, what you've probably all been waiting for, diving into the old chaos. Not only is it the farthest fall in the game, but it's definitely the most cinematic. It also has the unique property of having players take no fall damage on landing. How is this possible, you ask? Magic? We've gone way beyond physical reality here, as falls much shorter than this one are deadly, even in the game. But does this look cool anyway? Oh yes! This comes in at a staggering 411 meters tall. That's just a hint shorter than the Empire State Building. Now that's amazing. Thank you for watching this physics breakdown of Dark Souls 2. In the next video, I'll be going over projectile motion, finding out how several items and spells in the game behave when they're thrown. If you liked this video, please leave a like, and if you'd like to see more videos similar to this involving math, physics, and video games, feel free to subscribe. Thanks again! Re-entry drop in 3, 2, 1. Just kidding, I'm fine.